Hi, good afternoon. Well, today I'm going to talk to you about the design pattern that we are applying to the development of our smart contracts in our protocol. That implies like removing the access control decision from the coding time, or moving from the coding time the access control decisions to the deployment or configuration time. But a few words about me. I'm a Argentinian software engineer with more than 25 years of experience. Since 2021, I'm the CTO and co-founder of Ensuro. Ensuro is a blockchain-based reinsurance. We cover real-world risk using blockchain infrastructure. And well, let's go to the topic. First, let's start with an introduction. So regarding access control in Solidity or in the AVM, is typically, so first, all the methods are open by default. So that creates a problem, or let's say, unless we specify a rule, every method is going to be accessible by anyone. The way we implement that is with modifiers in each contract. Typically, the access control is used to restrict some operations to administrative access, like different roles. But it's also used for emergency posts, like for posting specific methods. We also, part of the access control scope is also defining time logs. And yes, and mostly it's implemented through the OpenZeppelin library that has several implementations for the different patterns that I'm going to go over and later to explain our pattern. And yeah, finally, I want to mention that also a lot of contracts are upgradable and use proxies, and that will become relevant for the next part. So let's start with the ownable. That's the simplest and oldest design pattern for setting access control. It's super simple. You just decorate the method with only owner, and that's all. It's easy, but it doesn't have any granularity. Like you only have one user that can do administrative tasks to any methods. So then we have the access control. This is the second most used. So this gives more flexibility. You can define different named roles for different methods. You still need to make decisions at the coding time. Okay, I'm going to use the same role for these two methods, or I'm going to create different roles for each method. And those decisions are made at coding time. And another problem is the access control configuration is done at the smart contract level. So if you have 10 contracts, you need to define 10 rules. Another special case is the posable contract. That is typically, like, I include this in access control. In this case, we don't restrict the access to the contract based on the user, but instead based on a given state of the protocol of the contract that says if the contract is posted or not. That is typically used for emergency posts and is also implemented with a decorator. But again, it's another coding time decision that you need to decide, okay, which methods are going to be posable and which not. Finally, we have the access managed or access manager plus access managed pattern. So this is a contract introduced in OpenZeppelin version 5 in December 2023. So for me, it's not so widely used, but it's a big step forward in the direction that we are presenting in this panel, in this presentation, because it allows you to, so first, it works with an access manager contract that concentrates all the access rules of a given protocol, of a set of contracts, and then the contracts are access managed, meaning that they delegate the access control to another contract, and so you just decorate the contracts. The only decision that you need to take at coding time is adding a restricted modifier. Then, at the configuration time, you can decide, okay, who can access, if the same role can access different methods or whatever. It still has the same problem, so has many other benefits. For example, the access manager includes built-in support for time logs. That is good, so you don't need to use a different contract to implement time logs. But you still have the same problem. that the decision of decorating which methods are going to be restricted is a decision that needs to be taken at coding time. So to summarize, like all these patterns have this set of problems, right? First, we have a hardwired logic, right? Access control logic. All the logic is hardwired in the code. You need to define which methods are going to be, like, in some cases more or less, like from the scope from going to auditable to access managed, but you still need to make the decision at coding time. And it's something that you can change. Another impact of this is the increased contract size, because all this goes to, is part of the implementation of each method, this check of, okay, I need to call this contract to check if this method is restricted or not, or if it's enabled or not. This adds a lot of burden at the testing time, because if you want to reach like 100 coverage, 100 branch coverage, you need to test all the special cases, like for each method, testing, okay, a non-user cannot call this method, but authorized user can call this method, and so on, like, and you end up doing a lot of repetitive tests for testing that kind of behavior. And also, for your normal test, when you want to test the logic of your contracts, you still need to do all the setup of setting up the rules and saying, okay, this is going to be applied by the admin. And the final effect is the bad observability, right? So you can't, it's very hard, once the code is deployed, to know what is the access control configuration of a given contract. You need to read the code, and from there you need to see, okay, which methods have this modifier, and based on that, you will go and check the access manager contract. So it's very hard to programmatically assess or understand what is the access control configuration of a given protocol or contract. So the alternative, let's move away the access control logic of our smart contract. And how we do it? We move it to the proxy, to just 3 lines in the proxy. So here we have basically the minimal version of the access managed proxy, the contract that we are introducing. That's just that. So first, let's recap. The ERC 1967 proxy is a standard proxy used for upgradable contracts, just receives all the calls and delegates the call to the implementation contract. What we are doing is, before delegating the call, we are calling the access manager contract to check if that method, based on the selector, is allowed or not for the user that is calling. So only with this configuration, we can remove all the access control logic from our implementation contracts. So the impact is huge. This is functionally equivalent to using the access manager of OpenZeppelin 5 and decorating all your methods with the restricted decorator or modifier. It has a gas impact, and this is also a problem. Typically, you don't want to add the possibility of adding access control to the views, because it doesn't make a lot of sense. Unfortunately, the EVM doesn't have a way to detect if I'm being called in a view or not, so it's hard to detect that. So one optimization we did is we allow to construct the proxy with a set of skipped methods. So those methods are going to be skipped of the access control validation. So in that way, we reduce so that part means that at deployment time, so in some part of the configuration will be done at production time. So we have every method that is restricted, then at production time, with the access manager configuration, you can say, okay, this is delegated to the public role. So that means that this method can be called by anyone. Or this is delegated to, I don't know, a back office role, and so on. That is configuration time. This is for a bit of optimization, the decision that you still can take at the deployment time. When you deploy the proxy, you can define, okay, this set of methods are going to be skipped, and then for gas optimization, we avoid calling the access manager. It still is much better than defining that at the coding time. And we will see, like, In terms of gas implication, so the gas overhead of using this approach is minimal, or it's exactly the same as using, like for a skipped method, it's exactly the same as using a proxy. So the difference is only 1,000 gas, 1,500 gas. And for non-skipped methods, it's more or less the same as using the access manager pattern of OpenZeppelin. So what are the benefits? Like no more hardwired logic in your contracts. So you remove all that code, all those modifiers. The implementation code becomes much more simpler. And as I said, like those decisions are postponed up to the deployment phase. And you might have like a different configuration. For example, you can do a closed beta where you deploy your contracts. Initially, all your methods are restricted to specific users that have a given role, and then you can make those methods public and you open your protocol to anyone. Like stuff like that is very simple to implement with this, and you have all that flexibility. In terms of contract size, we are also seeing like between 10 or 20% reduction in the contract size, and this is even more if we remove the pausable base, because with this you don't need anymore the pausable base. The access manager proxy, so the access manager contract of OpenZeppelin has a method that allows you to put set target closed, and then any call to a given contract is going to be stopped or paused or rejected, let's say. In terms of testing, for me, this is the best part, because when doing all your tests, you forget about testing about access control. So you don't need to test this method is accessible or is restricted or not. You don't need to do all the setup. And in your test, you can focus on testing your core logic. So our testing library or our JavaScript library that comes with this access managed proxy allows you to deploy the proxy with all the methods open. So for testing, of course, that is crazy doing that for production, but for testing is the perfect setup, because you just test the contract logic and you forget about the access control. And then a final benefit, and I think this is the most profound one, or the one that will have more impact if this is more used as a practice, is a better observability. Because now, with this, all the access control logic can be queried from the blockchain. You just need to query the access manager configuration or the proxy, perhaps for the pass-through method, for the skipped methods. But only that, just querying the blockchain, you can know what is the access configuration for a given protocol or for a given contract. Instead of, I don't know, going and reading and parsing the code and seeing which method have a given decorator. And this enables doing, like, as we do in Ensuro, we have a manifest where we declare what is our access control configuration in a readable format, and we have tools that monitor the access, the on-chain configuration compared to this manifest. And we have tools also to apply the changes so the on-chain configuration is the same as the manifest. So this enables a lot of benefits regarding making the access control configuration much more visible, much more transparent, and easily to manage. So finally, some final thought. So hopefully, first I expect that you like this approach and you start using it on your project. I'm open to questions in case you have doubts about it. But if this becomes more widely used and more standardized, so then the benefit will be very good for the ecosystem, because we will have a standardized way of reading the access control configuration. Now we have different implementation. I don't know, the other day I was reading the Morpho V2 code, And that is a great project. I like Morpho. I don't want to say anything bad about them, but they are like re-implementing or re-implementing a way of doing access control. And that is a problem for standardizing monitoring or for all the people that wants to track, okay, this contract is upgradable with 6 days of delay, with this amount, or this operation is done by this or that is delegated to a multi-sig. For doing with this, doing all that work is super transparent, super easy to do it. Without this, it's a pain. And finally, something I'm dreaming I would like to see in Solidity, some support for kind of a method that says pre-dispatch hook. So before dispatching the call to a specific method, some hook where you can put in Solidity code that allows you to put this. In this case, we can implement the same behavior that I presented here without the proxy. So it's kind of something that I think I'm not an expert in the internals of Solidity, but probably it's something that can be implemented. So thanks. Well, there you have, first, Ensuro website, in case you're wondering. There is a GitHub repository for the access manager proxy. At least it's a minimal code. It's not so important, but in case you want to use it. There is the link of the pull request where we applied that change to Ensuro. And finally, in case also there is an issue that I submitted to OpenZeppelin, so they can include it in OpenZeppelin library. There's kind of the standard library, and so you can go and vote. Well, thanks. I think we have time for questions.
We have time for questions. Okay. I will bring the people with mic.
There's no questions, so you can just go up.
There is someone raising the...
With those hands up high.
Thanks for coming here. Great presentation, thank you so much. In your hooks, basically, you're passing the message signature to the access manager. You're not passing the call data itself for the analysis. Now, you might have seen my ERC, it is 7746, where I suggested to doing the generic middleware hooks, which basically is very similar to what you're doing. The only difference is that I suggested to pass the message.data as well to the access manager so that you can have logic based on that. So what was your design consideration around that? Thanks.
Yes, sorry, I don't know if I get it completely, but I think you mentioned about like that we are passing. I'm passing only the selector of the method, not all the call data. I think that's so. First, because I'm building on top of the access manager of OpenZeppelin, so I'm replicating the behavior they already have in their code. So this is kind of it's just an elaboration on top of that, like instead of replicating with the modifiers. I agree that in some cases you may need to do something more granular, like instead of just filtering on the selector. Something that we are doing in some cases, we are creating fake selectors. So for example, I don't know, I have a given method, and then I can set up the rule to access that method. But then inside the method, I can call and I can ask the access manager about a given fake selector that is still 4 bytes and is generated with some part of the parameters. And then I can create more granular rules. So the idea is to, in that case, use the same access manager to hold all the configuration, but give us like enough flexibility. Well, any other question?
All right. Thank you very much, Guillermo.
Thanks.